Okay, well, let's go ahead and get started. I just want to say a warm welcome to everybody who is joining us this evening. We are going to be talking all about heat pumps tonight. So this is a webinar focused on heat pumps and how to get off of natural gas or fossil gas, as we think it should be more appropriately called. And we're just really excited to have Dave Petroy here, and I'll introduce him in just a moment. But first of all, I just want to say welcome on behalf of 350 Colorado's Renewable Energy Committee. So we're a committee that meets monthly. We're a group of volunteers that care about renewable energy and are doing what we can to advance renewable energy in Colorado. Right now, we are focused on education, and we're offering webinars every month or two on different renewable energy topics. So we hope you'll come back and join us for a future webinar as well. And for those of you who don't know me, I'm Deb McNamara. I'm the campaign director with 350 Colorado and also am a part of the Renewable Energy Committee. Can everybody hear me okay? I just want to make sure if somebody can, okay, cool. Okay, sounds good. So I'm going to go ahead and introduce our presenter for this evening. And just to let you know what the schedule of the evening looks like, Dave is going to share a number of slides with us, kind of getting into the technicalities of heat pumps and everything we need to know for those of us who are looking to make this transition. And he's going to speak for about 25 minutes or so, and then we're going to have time for questions and answers. So I invite you to type your questions to the chat, and then I will be fielding questions as we get, as we get to that period. And we may be able to unmute and have some open dialogue too. We'll just see where we're at. But feel free to put a question at any time. And Dave is also available to answer questions after this webinar. So if we don't get to your question, don't panic. Dave is a great resource, and we actually have a couple of people on our Renewable Energy Committee who are really great resources. And so we'll be happy to help you after this webinar as well. So I'm going to go ahead and introduce Dave. So Dave Petroy is a member of our committee, and he has over 15 years of experience in a range of renewable energy and sustainability and business roles. He was the founder and president of Blue Valley Energy, which was a successful ground source heat pump engineering, design, and installation company in Boulder, Colorado, with over 200 installations throughout the state. During the early 2000s, he led technical sales of solar and energy power systems for residential and small commercial businesses at RMS Electric. Most recently, he was sustainability manager for Golden Aluminum, one of the largest single-site industrial power users in Colorado. There he was responsible for the adoption and implementation of a facility-wide energy monitoring system and upgrades to reduce energy consumption on large industrial production processes. In 2017, he launched NTS Energy, a consulting company focused on providing advancing HVAC and solar solutions to homeowners and small commercial and industrial companies. And with that, I will hand it over to Dave, who's going to begin his presentation. Thanks for being here, Dave.
Thanks, Deb, for the introduction, and thank you everyone for taking time out of your evening schedule. Something to drink and something to snack on. Got a lot to cover. I'll try to get through it and get to a lot of your questions. So let's let me share my screen, and we'll start talking about heat pumps. All right, so it's all about heat pumps, big benefits for you and the environment. And I'm going to start a little philosophical real quick and a little big picture. So, everyone can recognize this is our home. This is the Front Range in Denver. And I want you to think about this is just a couple little developments. And probably every one of these hundreds of houses most of them probably have gas furnaces, gas water heaters, and gas appliances. And so we need to think about each of these. If we can start to transform this quickly, about every 100 houses might actually be able to shut down a gas well. And I'm sure all of you heard of this. Everything you do matters, and you have the power. I'm not going to read it all. You have within you the power to change the world. And I think being in this movement, you hear a lot about we've got to do government and we've got to do these big picture things, but also at times I hear individual action's not enough, but we really, that's a key component, and we can do an amazing amount of stuff with that. So in order to give you just a little quiz here, the size and the speed of change, I'm going to say, so June 29, 2007 is the first one. And today, 13 years later, we have 5 billion of them. So I just went to the answer. But anyway, I was hoping to have a quiz on that to see if anyone could answer in the chat. I was trying to find that. But I'll just go with the answer here. Obviously, it's cell phones. And, I actually pulled this off, and I think it's an Adele concert, which I was lucky enough to go to. But imagine every one of these points of light. In 2007, there would have been none of these points of light. So imagine each of these is a house instead of a cell phone. And each of these houses went from burning lots of gas to not burning gas. So we have the ability, just through market forces and through our own individual actions, to make these changes quite rapidly. 13 years from now will be 2033. We want to do this transformation in the next 10 to 20 years. So basically, this is sort of my call, and hopefully I can encourage you by the end of the talk to get excited about considering maybe some heat pumps for your own home. So there's a big move in beneficial electrification. There's a national organization. There's a Colorado organization. Many people from diverse groups participating in it. The key thing, the goals are the grid's going to be, let's call it 80%. I'm going to say clean. It's 2030 relative to 2005, but with Excel and Tri-States moving the same way. But we all know that sometime 2040 to 2050 it'll be 100% clean. Hopefully, maybe the technology will move even faster. So the goal over the next few years, and really key, is in conjunction with that, how do we get every new home built in Colorado to be 100% electric? How can we make this happen by 2025? This is a very big lift, but it's important because for every home that's built now with gas appliances or not efficiently, that home is locked in till 15 years, so close to 2040. So we all need to kind of work on this transformation and just changing how we do things. So that in addition to new homes, we got to try to transform all of our homes from gas and propane to electrification. That's really got to be accelerated by our own individual decision making. So I'm going to run through the exciting evolution of heat pump technology. Then I'm going to talk about if you have a gas furnace and AC, how might you incorporate heat pumps into your home? Touch on propane, the applications of mini split ductless, their choices building a new home. Touch on the domestic hot water heating, new opportunities, and finally, like if you're going to take action, a couple slides to give you some hints on who to call, what to do, and then we'll have some questions. So obviously, I'll start out with what is a heat pump. And I think, this is pretty basic, but obviously we're evolving. We burn things to create heat. Heat pumps are heat concentrators and movers, and that's why they're efficient. So basically there's energy outside, and you're concentrating the heat, and you're moving it with refrigerant, which is a pretty magical liquid that likes to absorb heat and move the heat inside. But don't be confused. Cold air contains heat. And even if it's 0 degrees out, there's a lot of heat. It's just distributed more. You can still take that heat and move it inside. And air conditioners are just one-way heat pumps. Basically a car that only goes backwards. I really wish that I could switch the wording around, and heat pumps are really air conditioners, and air conditioners are really just coolers. And the other thing is, this is not some newfangled technology where you're taking a risk. The development has been fantastic over the last 10 years, but the technology's been around for a long time, and there's basically air conditioners, millions of them installed. So for those of you who want to get a little bit more understanding about how a heat pump works. And if this isn't detailed enough for you, you can email me sometime, and I can send you references to get into the real nitty gritty. But let's just start at the bottom. This on the right, this is what's inside my house. On the left, this is what's outside my house. And in here is refrigerant. And remember, I said refrigerant is a pretty amazing liquid. It likes to store a lot of heat, likes to transform from gas to liquid at low temperatures. And so it's perfect for this application. What happens is here it comes through this little valve, which is actually outside. It expands, so it cools off by expanding. And it goes into your outdoor unit, and it goes through a set of coils. As it moves through these coils, the unit's pushing air by it, and it's warming it up. Now, if it's 40 degrees outside, it might not have to move quite as much air, and it might pick up more heat. Whereas if it's 0, it actually might have to move a lot more air to pick up heat. And I'll touch on that a little bit later. And that's why the efficiencies will change as it gets colder. It comes up in here, the refrigerant moves up through this thing called a reversing valve. This is the only difference between an air conditioner and a heat pump, is this valve that allows it to go backwards. And in there, it moves up, and now it needs to be compressed, because the refrigerant, when it goes into your house, into the coil in the inside unit, which is above your furnace, needs to be about 120 degrees. So if it doesn't quite get to a high enough temperature here, you add some energy, you compress it, which makes it into sort of a warm gas. The amount of energy that goes into here will be more in the cold winter, because a little more energy has to go in. It'll be a lot less in the milder temperatures. Goes in through here, it goes through the coil it's basically this whole coil's at the top of your furnace. You're blowing air by it, the air warms up, goes in your house, heats your house, goes back, process just continues. And when this valve reverses, it's just the opposite. So that's kind of a real quick overview of how these heat pumps work. Now, there's perceptions out there, and in the industry, and I think, to some extent in the public that knows about heat pumps, and the few perceptions that their capacities are inadequate and inefficient to heat at outdoor temperatures below 32. They're best for milder climates than in Colorado. And for cooling, heat pumps are much more expensive to install an equivalent size air conditioner. And I'm going to touch on all these throughout my talk. But one thing I want to point out, that we have a beautiful, diverse state, but an amazing diversity in climate also. These are all the different climate zones. Yellow is the mildest 4, all the way up to climate zone 7. And for those of you from back east, that would be the equivalent of Maine to Southern Virginia. In fact, we're the only state that has 4 climate zones. So what have the engineers been able to spend their time doing to make heat pump improvements? And it's kind of exciting because there's lots of components that they can work on. Number one is that compressor, which compresses and adds a little bit more heat or energy into the refrigerant. That's the main energy consumer. And they've gone to multiple stage and variable speed compressors. It used to be the compressor just was on, like an old, power muscle car, and then off. Now they're fine-tuned, and they can put as much or as little as you need. In conjunction, inside, variable speed blowers. So the blowers at the bottom of your modern furnace, or if you have not a furnace but all electric, that's very important. And the controls to match these two. So really what you're trying to do is just enough energy when it's 40 degrees out, just enough air to keep your house constant 72. Not turn it on, blow hot air, turn it off, on and off. The other thing is some in the alloys of the exchangers, they've got improved heat design, grooved coils, etc. And finally, they've worked a lot on frost retarding and defrost at cold temperatures, and that what enables these now to work at temperatures below 0. So so let's talk a little bit about the 2 amazing improvements over the last 10 years. So the bottom axis is from around 2012 to 20, basically over about the last 10 years. So they've been working on these improvements. And HSPF is heating season performance factor. And for those of you who want to know all the terminology, I have a slide, not at the end, but yeah, I can send to you at any time to explain these. But basically, the higher number, the better. And over the last 10 years or so, we've gone from 8.2, the best units now are up to 13. Many units are available in the range of 9.5 to 11. There's lots of very high performance units available. And look at the improvement in efficiency, 34, 59%. This massive efficiency improvement is what enabled to call it what I'm calling a tipping point, which I'll talk about in one of the slides down the road. Number two was, and this is with cold climate heat pumps, and the improvements is people said, well, they don't have the ability to heat my house when it's really cold. And this slide on the left at the bottom is outdoor temperature, 0, really cold to the left, and it goes to 60 in the right. And on the vertical axis is the amount of heat you need. The green line, so I'm looking at like a 5-ton, so let's say it's be about like 2,000, 2,500 square foot home, or like a 5-ton heating load. And this is the amount of heat energy you need to keep it warm. So obviously it increases as you get colder. These are curves of how much energy a heat pump can put out. The old tech, notice it's the bottom blue line. When it gets cold, it was a long way from the green line. There was a lot of energy, a lot of heating capability it didn't have. But over time, they've keep increasing the capability of the heat pumps and how much heating they can put out at very cold temperatures. This is, you'll see the term cold climate heat pumps. And so now you notice that there's actually not much gap between these at 10 degrees. So in fact, the heat pumps can do almost all of your heating. This triangle here is sort of where they're a little bit short. It looks like a lot, but our climate, we're not in that triangle so much. So you can actually use a little bit of supplemental heating with your heat pump and heat your entire house. Or if you still have, your furnace, your gas furnace in there, you're not going to be using it very much. You're not going to be really burning much gas to do this. So let's talk about a couple scenarios, and I put the pictures there to try to liven it up so it's not our words. I mean, obviously, we've been dealing with a lot of the right this summer in the last couple of years, and even if it's not smoke from fires, we don't want to have bad air. We want the left. So let's say you're in the Front Range, you're on Excel, and your AC is old or failing. Let's say it's 10 years old or it's going to conk out soon. Why would you want to replace it with a heat pump? In the past, you'd call the guy up and say, my AC is failing and it's hot out. I need to get a new one. So there's two big reasons. Heat pump is a heating cost hedge against unexpected natural gas price increases over the next decade. And I'm sure all of you are more than familiar with the whole history of fracking and the pricing and everything in the Front Range. And price increases and all that is a problem. And you can dramatically reduce your natural gas for heating. So if you're going to show people pricing and everything, you got to sort of see where things come from. I wanted to give you an idea here. So this is natural gas prices, Excel, winter prices. This is Katrina. It's not been that. It's been going down since 2008. But below the red line is sort of break even roughly. So last few years, the industry is really not really losing money. Right now, this winter, our natural gas price will be slightly below this red line. But when I look at slightly above it, which is about a 10 to 15% increase, is very likely over the next few years. But it will go up and down. This is potentially the most important slide in this whole presentation. This is what I'm calling the tipping point. So in the past, when someone would come out and tell you the heat pump, they would have to say that operational costs are more than gas when it's inexpensive. But let's look at this. So this might surprise some people. This is the outdoor temperature range that you require heating or cooling. So cooling really is only roughly, we're still a heating dominated state. It's around 10%. It might be 10, 15%, depends on your house, but it's not a big percentage. I think this is what was surprising people. Between 62 and 40 degrees, really mild, 30%. 40 to 25, 40%. And here's the thing, when it's really cold, we think we're using tons of energy. We are, but it's not that many hours. So you're down around 20%. Now let's look at each of these times. So here I go out and I say, well, I can buy an air conditioner, I can buy a heat pump. I'm going to buy an energy efficient one. Both will have the same amount of savings as long as you're buying apples to apples. Here's the real key, right in this zone here. 30% of what you use. The air source heat pump, you can set it to 40. Let's say you keep your gas furnace in for now. You don't want to pay any more in energy. Eliminates gas use in this range, 30% of your gas. Reduces GHGs for the same annual cost at the current low gas prices. This is, with the evolution of technology, you could not say this until the last couple of years. That's the key thing. And now for many of you, you might be willing to pay more to reduce gas, but for the tipping point to try to convert all of those houses that I showed you in the first picture, that's a key thing. The other part that's important is in this big block here, the 40%. The same thing. It's going to eliminate gas use, reduce GHG, same annual cost at about 15% higher gas prices. So gas prices don't have to go up much for you to all of a sudden say, I could run my heat pump to 25. All of a sudden, 70% of my energy, my gas use is going to go down. I'm going to cut it out. So you have an appliance to heat and cool your home, which has the ability to help with gas use and still help you. Let's do a couple quick examples of this. So let's say 93% furnace and a heat pump, which is 18 SEER, which is a pretty good one on the market. A 4-ton house, which is say 2,000 square foot. So this is the bottom axis is the natural gas prices. This is the average cost, annual heating cost for this model. So the gas furnace, so right now our pricing is about just over, this winter XLs will be somewhere in here. And so you're going to set your heat, you have your heat pump, you have your gas furnace, and the contractor sets it 40 degrees changeover. So your pricing is going to stay the same. Now, over time, next winter, gas prices go up 15% more. All of a sudden, you can heat with the heat pump more, you can cut the gas use, and you can start to save more money. So this is just a specific example of what I was trying to show on the previous slide. This is a complicated slide, which I tried a lot to make simple, but let's just look at the colors. Start by the bottom. Fortunately, I got it flipped backwards compared to them. Warm is on the left, 55 degrees, outdoor temperature. Cold is on the right, 20. So the gray area is the amount of heating, your annual heating provided by your gas furnace. The green is provided by the heat pump. Now you have a tool. You have a heat pump that can help you. So over here, say, I just run my gas furnace all the time. But let's go down here, down to 35 degrees. Let's say I want to run my heat pump, and I'm gonna heat my house down to 35. Then I'll let the furnace take over. So the changeover, you're gonna 45% heating with the heat pump, and you're gonna cut your natural gas use. And surprisingly, because of the efficiency gains, you're only gonna pay, say, 5 to 10% more, which, depending on your bill, might be $100 a year, might be $200, it might be a cup of coffee a month. And even if you want to get more aggressive, depending on how much more you might want to pay to cut your gas use down, you now have the capability. So how much gas am I saving? Let's try to put it in. And here's a way to look at it. I hope people have seen the beautiful hot air balloons we have around here, but This is kind of from an average car. This is how much CO2 that you actually have in a year. And this is, now I can convert all the CO2. It gets a little bit crazy sometimes. This is, say, the amount of gas for a home that uses 1,000 therms, which might be, the 2,000 square foot house. So here you got your 1,000 therms. So I want to try to show people, because they want to say, well, how does it compare to, like, I buy an electric car? So you can buy a new heat pump, and you can set the changeover temperature to 40. And remember, I showed you that changeover. And you can cut this left balloon by 1/3. All of a sudden, I'm using 1/3 less gas. If you want to pay a little bit more, or gas prices go up a little bit, I can now set it to 20. I can cut this balloon by 2/3, I can cut this balloon by 3/4. So you have the ability to have a big impact on your use of gas and the effects on Colorado. Set my timer, but let me keep going a little quickly here. So propane varies a lot more. I don't want to spend a lot of time. These scales are the same compared to electricity. Propane's like 3 times gas prices. So if you live in a part of the state, or you have a home that's on propane, this is the blue bars these are all the different climate zones. How much money you'll spend, $2,500 to $3,000 versus 1,000 or 800 with gas. This is how much you'll save. The gray, 1,000 to 1,500, and the percent savings, the yellow, varies anywhere from 30 to 50%. So with propane, all the advantages I was just talking about, except amazing savings. This was just one quick thing. Now, this is with furnace and AC and a heat pump, and it says, okay, you put this in. Tri-State happens to have amazing rebates. You save this much money, so your incremental cost is less, immediate payback. Even if you didn't have the AC and this was less, with propane, if you put in a heat pump, whether you and you could put in a heat pump without any propane at all, or keep it in for a little bit, you save a tremendous amount of money. Even in worst cases, like 3 years, you'll get your money back. And you can even finance. You could finance it for 5 years. Your annual cost will be less. You'll pay it off, and then after 5 years, you'll be saving tremendous amounts. So propane is fantastic. A lot of you probably heard of what's called mini split or ductless heat pumps. Another great technology evolution. They've been around a while, probably since the late 1990s. They're really good for new rooms, addition, uncomfortable rooms, wings, or you could take the second floor if you have a second floor that's always hot and you can't zone your ducts. It can help. Electric resistance baseboard heating is very expensive. You could do it for cabins if you have cabins that are on propane. So you have flex, and the advances are very nice, different indoor units. I'll show some pictures. They're aesthetically pleasing. They can fit in a lot more spots, and you can have multi-zone systems, which means one outdoor unit, multiple indoor units. And versus electric, if you have baseboard heating or propane, electric heating, it's 65%, and I showed in the previous propane, it's quite a bit also. And these are very nice. I mean, right now they actually make units where up in here you can sort of hide the little indoor main blower unit, and you can run these mini little ducts. So all you show in the ceiling is little vents. They have these flush mount ceiling units. Everyone's seen these on the wall. These are more floor units. And if you haven't heard of these, I've been in bedrooms with these in them, and when you set them on low, you can go to sleep, you can't even hear them. It's really fantastic technology. Second most important slide, building a home. Remember I said, how do we get change by 2025? How do we not build thousands of homes and have gas in them? And does it make sense? Well, let's look at this. So I'm calling it outdated in some sense, because the technology is really becoming outdated. And some are gas. Not all gas is outdated appliances. So over here, you put a gas furnace in, you put an air conditioner in, you put a gas water heater, you put a gas stove, you put them in, you're going to get $10,000 to $15,000 roughly. And over here, now what can you do? You can put an air source heat pump, does heating and cooling. I put ground source heat pump. It's a great technology. I did it for many years. It's not the focus of this talk, but in some cases that could be a good option. And now heat pump water heater, which I'll talk about in the next few slides. Put those in roughly the same cost. I put this together and I did these and I'm like, oh, it's exactly the same. So I don't need the idea that, yeah, it's, Dave put the fix in. I mean, basically the idea is the initial cost is pretty much the same with the opportunity potentially to eliminate a gas line tap, depending on if you have your own land and you're building yourself, you could save quite a bit. If it's with a developer, it really depends on the situation, whether you would have this ability to save money or not, but it's just something to be aware of. So what would happen if I went out and built my house, and on the left side here, I put in a beautiful Carrier heat pump, and I got a gas furnace, 96% efficient, and I'm going to spend, and this is with Excel pricing, current pricing, $822 a year, and this is that same size house I always do. Now, I've just to show you the availability. This is 3 different manufacturers, really nice heat pumps, 19 SEER, 10.5 HSPF, and no furnace backup, a little bit of electrical. So right now, oh, it's a little bit more, Dave. That's not so good, what you told us before. However, the deal is you don't have the gas connection fee. But Excel is $13 a month. And notice, pretty much close right on about $13 a month. So you can heat and cool your house, 0 gas, for the same price as this, same investment cost. In fact, right now, I got to get rid of my gas dryer. I'm paying $13 a month to use $1 worth of gas a month to dry my clothes. I'm almost done. I don't know how I'm doing in time. I have my timer set. A couple more slides. I'll be quick.
It's 6:35, just to give you a time.
4 more minutes or so. I just want to mention this real quick. So in the past, you have gas water heaters. Now you have power vent, electric, and then regular electric, tankless, and now you have hybrid electric, which is heat pump electric. And this is the energy factor. This is the percent improvement. So it's, it's using heat pump. It's moving heat. It's very efficient relative to these other. Now, when you translate that into cost, old electric water heaters, expensive. Now, the heat pump it's close to all the rest of the gas options. Tankless a little less, but this cost differential is, on the order of $20-30 a year, something like that. So a few dollars a month, you don't need to have gas. You can have the hybrid electric. Here's the gas use. So this is like about 10% of this would be in therms, about 10% of your gas for heating. So just to put it in perspective, it's not massive, but it's not negligible. You have the ability to eliminate that use. I got a couple slides on talking. If you want to take action, what do you do? So let's talk about selecting a contractor. Heat pumps aren't new, but to Colorado, they're sort of new. People do them, but you don't see them advertised all over. But there's, the idea is how do we make it happen fast? So recommendations from friends, obviously, is number one. You can go to the manufacturer's websites and find high quality certified manufacturers. I would say this is a key one. Do they emphasize heat pumps on their website? So you go there and you look around and you say, they have heat pumps kind of on the top tabs. Is it buried? Can you find out about heat pumps? You call them up, you say, are you guys doing many heat pumps? So they're going to be like, yeah, we do heat pumps. Or you'll be like, we don't really do them. I would, my recommendation, having been in the industry, you get 2 quotes to start. A lot of people get 3 quotes. Quotes take on time, and if they're doing it carefully, it takes some effort. If they're far apart, get a third quote, and I would be pretty cautious of really low quotes. And if you're like, well, Dave, this is great, but I still can't, I'm on the fence between air conditioner and heat pump. You can fairly negotiate the heat pump price. If the price is, $1,000 different, you can say, well, hey, can you take a few percent off and get the heat pump closer? Quickly, I want to go through, this is really key. So someone comes out, and this is the heat pump versus AC replacement cost. It's a big range, but a lot of these things play into it. So you'll come out, this unit, with the outside unit, be the same size and the shape. Heat pump will be on a standard pad. The line set units, they can evaluate that. They'll evaluate that line set. They can pressure test it. They can check it. If it needs replaced, it'll need replaced for both of them. Same deal. The coils at the top of your furnace, usually they'll want to replace those more often than not because it helps with efficiency, and often you won't get rebate or Energy Star credit. The big thing that'll come up, depending on how old your furnace is the technology gap between the outside unit and the blower inside. Remember I said, both of them are all the efficiency gains. And so if this is very old, it might not be compatible with it at all. They might say, you got to replace your furnace or put an air handler in, a new one. Or they might say, yeah, we can do it, but it might compromise the efficiency. And that's not terrible, but it's something for you to decide. And finally, controls. Like each of these products have really great controls, great thermostats, but they might give you a couple levels of control to choose. You want to talk about loads if you have a new home or total system replacement. So this is important. It's really relatively easy to take, if you have a 2-ton air conditioner, to put a 2-ton heat pump in. If you have a 3-ton air conditioner, 3-ton heat pump, because you don't have to mess with the ducting. And I can maybe go into this in a question or two. Even though the heat pump isn't big enough to do all the heating load, it'll still do a lot. And changing all the ducts and everything can be a big deal. Okay, there's the weatherization program. There's this interesting financing program. Manufacturers have financing, but it's called Renew. There's some nice rebates. Excel, you can look on their site, but $500 to $600. Tri-State is tremendous, $450 a ton. And also many of the co-ops have additional rebates on top of that. And I haven't put it up, many of the municipality, like Longmont and Fort Collins have some really good rebates too. So summarize, large improvements. They work well in our climate. Instead of AC, they provide protection against price increases, dramatically cut your gas use. Against propane, it's same benefits, but tremendous savings. Heat pump water heaters, finally, you can not use gas to heat your water, and finally the costs are really very close to the most efficient gas heaters. And that's all I got.
Thank you so much, Dave. Really appreciate all of the expertise and technical advice, and hopefully folks who came in with questions, hopefully some, if not all of your questions may have been addressed in Dave's presentation. But thank you, Dave. So we'll move into some questions, and I just want to note that I know we were aiming for a shorter 45-minute webinar. And so for those of you who need to leave right at 6:45, feel free. I'll just say thank you right now, because I know some folks will be moving along to the rest of their evening. But Dave is able to stay until 7. So those who want to stick around and talk, ask further questions and hear the answers to the questions asked so far, please do. But I just wanted to say thank you for those who might have to join it or might have to leave in a few minutes. So we did have a number of questions in the chat. I'll just start with the first one, or one of them. Can heat pump systems be used with heat systems using water as well as air? And Dave, do you want to add anything to that or clarify?
I guess the question has to do with radiant in-floor heating. There are a couple of manufacturers that make air source heat pumps that they are promoting to do radiant in-floor heating. And to tell you the truth, I haven't really evaluated them yet. It's on my to-do list in the next 2 weeks. You know, people are working very hard on this. You know, is the technology quite there yet? Without getting too far along, my guess is that it's probably there, and you might need to have like a little electrical in the storage tank to boost it up during the really cold times. So that technology is coming along, like I said. And if you want to send me an email in 2 weeks, I'll be a lot more knowledgeable on all the real details of that.
Great, thanks, Dave. And Dave, I know you said that folks could email you directly as well. So
Yeah.
At any point, feel free to put your email in the chat. And then I also just wanted to note, as a couple of people have asked about your slides, and I know someone just asked about the weatherization slide. If you email me, I can share, or Dave, we can share his presentation. So I'll put my email in the chat too, because there certainly is a lot of information that folks might want to reference again from the slides. So let's go ahead and move to the next question. What would the energy source for the electricity be? It was a question and a comment. Not coal. Yes, we hope it's not coal. So Dave, I don't know if you want to say anything else about that, just the desired source.
Well, there's the advantages really multiply. First of all, obviously, if you have solar on your house in the winter, during the day, a lot of that time you're sending it back to the grid, which you lose. You know, there's some loss, whereas you're actually using it for your house. The other thing is, I didn't put it in there, but right now, if you look at where you displace that portion of your heating, not only you cut the gas way down, but the current way our grid is, the renewable sources, it does cut the GHG down by, I think it's around 20-25%. But the interesting thing is, if you look at the projections over the next 8 or 10 years, suddenly that GHG reduction grows and grows and grows. So all of a sudden it's like 50% or something. And actually, obviously, when you get to near 2040 and the grid's almost 100%, you know, you've suddenly reduced your GHGs by almost 100% too. So that's what's exciting, and that's why it's important that we try to convert over as soon as possible.
Great, thank you. Thanks, Dave. Someone had made a comment about hoping that you're going to explain and evaluate the efficiency of heat pumps. Do you want to add anything further regarding the efficiency of heat pumps?
I think that my recommendation, if you're going to go out and look at them, you should look at a heat pump with HSPF of about 10 or more. There's a lot. So if you look at each manufacturer's website and you take kind of their top, most of them the top of the line product series and one below, those two, that's what I would focus on. Which the HSPF and the SEER are kind of related. They're hot and cold, but they tune the efficiency. So you're looking at things that are around SEER 18, 19, and HSPF greater than 10. So I would focus on those.
Okay, thank you, Dave. Do today's heat pumps use HFCs for refrigerant? And if so, can you comment on the estimated greenhouse gas impact?
They do. They keep phasing out the older stuff and coming up with new stuff. But honestly, I'm not a guru on the refrigerants. I do know that the contractors are supposed, they're required by law to capture the refrigerants when they have to replace things, dispose of them properly. I mean, it's a big area, but I know that they keep going. I can't remember when the next transition to a more benign refrigerant is, but I'm not really a guru on the refrigerant part of it.
Yeah, no, that's also helpful what you just shared. And I just want to invite, because I know we have folks on the call who know a lot about heat pumps, already have heat pumps, and looking to learn more. And Harv Teitelbaum from Physicians for Social Responsibility is also on this webinar. If anyone has extra information that you want to share, go ahead and put it in the chat. If you know more about the HFC issue, feel free to answer in the chat too. Is any of this technology applicable to radiant heating via radiators?
That would be really hard because radiators require a really high temperature. So my answer previously referring to a couple manufacturers producing air source heat pumps referred to in floor, which, the temps are like 110, whereas radiators are very high. Rather than go that strategy, if you have radiators, you might be best to look at mini split systems. And what you could do is say, you could easily install, depending on your house, but let's say a mini split system in your second floor. And you have up to 4 units, assuming they're kind of balanced. And so 4 units, a lot of flexibility. And then literally you could turn off the baseboard radiant for that whole floor. So now all of a sudden you wouldn't be using it for that. The other thing, there are ground source heat pumps, but really baseboard radiant is very ineffective way to distribute. So really the strategy is to think of better ways to put in systems to distribute heat around your house better.
Okay, great. Thanks, Dave. And thank you for going through all these questions. We have had quite a few, but a lot of these can be answered pretty quickly. With a hybrid electric water heater, isn't it grabbing heat from the furnace heat pump? There's some extra cost and load on the heating side.
Great question. Super hard question. So the way to think about that is, so let's just say, like in my case, that I put a heat pump water heater in the storage room in my basement. So you need a big enough area. So what it is actually grabbing heat from your house, definitely. The thing is that it's concentrating it. So what you might be doing is, depending on the area, and it requires some air exchange, you might be lowering the temperature of that room by 1 or 2 degrees. So if you think about it, you're not necessarily going to suddenly be running the furnace or whatever heating system to always make up for that. And also for a lot of the year, it depends where it's located, et cetera. You have internal heat in the house, you have extra heat in the house that you kind of want to get rid of. So it's a really good question. To get the exact answer is very difficult. I will just say that, if you take an electric water heater out of your house and put in a heat pump water heater and knock your bill by a couple $100, you're not gonna have it go back up. You're not gonna run your heating system in your house to make up for it. So it's like I said, taking a bigger area of our house and reducing the temperature of a little bit. The other thing is, if you're building a new house, I'd be really thoughtful about where I put it. Like, if you could put it in a closet on kind of the south side of the house, where it's heat on the first floor or something, if you think about where you might put it, where there's sort of extra heat in your house that you don't need. Ideally it would be the attic, but I wouldn't stick it. I wouldn't put water way up there. So great question. Very tricky question, actually. Very difficult to answer.
Great. Thank you, Dave. So someone asked, I have a gas furnace. If I add a heat pump, will that add AC too?
Yes. Yes.
Okay, great. Thank you. And are there any safety hazards?
No. I don't know if it's related to that. Oh, to the prior question. The one.
Different question. Yeah.
No, not. I don't know if it's related to. No, there's not really safety hazards. I mean, a heat pump's like an air conditioner run by electricity. I mean, in terms of safety, if you slowly convert your house to all electric, then you've actually increased the safety of your house and the indoor air quality.
Right. Yeah. Thank you for reminding us about that. And I don't know if folks saw, PSR is doing quite a bit of work on this issue, just looking at the health impacts of using natural gas. So for those that want to learn more about that, Physicians for Social Responsibility is a great resource.
And I would, given the way things have been the last couple summers, and you want to keep your house sort of buttoned up, I would, people need to think about that. I would actually encourage people to think about, you might call your HVAC person at the same time and ask about what kind of like whole house filtering systems would work. Certainly, if you're going to do a heat pump, consider that, because you can put the system on circulate, and that that would help also.
Okay, we have just a couple more questions. What's the average lifespan for an air source heat pump and a mini split heat pump?
It's about the same as an air conditioner. So 12 to 17 years.
Okay. Okay, great. Thank you. Okay, here's another question. I cover my AC in the winter and don't worry about snow and ice damage. I can't do that for a heat pump, which will operate in the winter. Can a heat pump be compromised by heavy snow or even damaged by icicles falling from the roof?
Well, that was the one slide I mentioned about. I mentioned the bottom of defrost modes and that. The cold climate heat pumps are designed to operate all year round. So your contractor will put them up on it. The difference is they'll put them up on a stand or a pad to get them up above the snow, so they can operate and get good airflow year round. The defrost mode, if they have to kick in, sometimes if things build up, they'll defrost. I would maybe have the contractor put a shield above it. I mean, I wouldn't want to have big, heavy icicles from my roof like plunging into the top of the heat pump. I mean, it could damage the fan blades and stuff. So, think about where you're locating it with regards to that.
Okay, great. Thank you. Any change to the service panel needed?
If you don't have AC now, yeah, you'll probably have to upgrade you might have to upgrade your service panel.
Okay.
It depends how much extra capacity you have in your electrical service.
Okay, great. And I just want to thank folks for the resources that a couple of links have been shared in the chat too. So thanks everybody for that as well. Okay, hopefully another quick question. I've heard that the recovery time of a heat pump water heater is not as fast as a gas water heater. Is that true?
Actually, it's not true because it's very interesting. They've designed the hybrid water heaters to actually have three very different operating modes. For the most efficiency, you can set it where it uses the heat pump the most. Then there's a middle mode that shares heat pump and puts a little more electrical. And then there's a third mode, which is even goes to more electrical. So you can set it to the most energy efficient mode. And if you do need, if that's not quite adequate for you, you can shift it to another mode, which is uses electrical a little more to give a little faster first hour rating. I've looked at the first hour ratings though, and they actually seem quite good on the heat pump. So that really shouldn't be a concern.
Okay, thank you. What does air source heat pump mean exactly? Does it not use pipes below ground?
That's the difference between air source heat pump and ground source heat pump. Ground source heat pump uses pipes below ground. The air source means it's just taking air through the unit, and that's where it's drawing the heat from. Ground source, which has the pipes, you either drill holes or dig trenches and lay pipes in the ground, and circulate water through the pipes up into the heat exchanger, and it's basically a coil within the coil. So what happens is the water from the earth comes up and it's warm, and the refrigerant's on the other side. There's a thin wall, and it sucks the heat out of the water. So that's called a ground source heat pump, and that's where you have the pipes. And you either drill vertical holes, or if you have lots of land, you can dig like 6-foot trenches and lay the pipes in.
Okay, great. And y'all have so many good questions. Dave, thanks for giving us all of these technical answers. So we have 3 questions left, and I think let's, I know a couple more just came in the chat. Let's just we'll end with these last 3 questions, and then we'll close. And then do remember, if your question wasn't answered or something else is coming up, you can email either Dave or myself. And Dave, let's make a point to put our emails in one final time before we close. So, okay, what kind of compressors are used in the most efficient pumps? For example, only piston?
They're if you look, they're called the inverter controlled compressors. So the evolution of compressor was 1 speed, then there was 2 speed, then there was 3 speed, and now they're inverter controlled, which means they're basically and they're scroll compressors, and they're essentially infinitely variable at this point.
Okay, thank you. And can the air heating and water heating be combined?
No, not with air source heat pumps. With ground source heat pumps, you can get called a de-superheater, which will preheat the domestic water, but not with air source heat pumps.
Okay.
Now, units that I don't know a lot about yet, which I'm going to be researching, that provide the radiant inflow, I'm assuming they might have that capability. But in general, no. In general, that would be where I would apply the keep it simple rule. Hot water, domestic hot water heat pump, and then heat pump to heat and cool your house.
Okay, great. Can you use air source heat pumps with a gas water heater, specifically a gas-fired tankless?
Trying to think. Okay, so if you're asking, you wouldn't need, if you're asking for heating and cooling, you wouldn't really need to combine them. It wouldn't make sense to like somehow use your gas-fired tankless. I guess what you're asking, that's a good question.
Yeah, and it's okay if you're not sure. Yeah.
I think it would be very complicated to do that. I mean, you could potentially do that. You could have like a blower in the bottom and then have a hydronic coil and another coil. That would make for a more complicated system than you might want to do.
So it sounds like maybe, but further.
I mean, I actually send me an email with a specific situation. I'm not really sure what the situation is.
Okay, and I don't remember who asked that question. So if you're still on, Dave just put his email in the chat just a few chats back. Okay, last question. It got in right at the end before I close questions off. Can a heat pump entirely replace my forced air gas furnace in California?
Absolutely. I just have friends in LA who just did that. And in California, it's easier because they're milder climate. Absolutely. In fact, I don't know why they sell gas furnaces in California anymore.
Okay, great. Well, I want to say a huge thank you, Dave. We just like rapid fired about, I don't know how many questions is that, 25 questions to you. So thank you. And Dave, yeah, do you want to say anything in closing, and then we'll hop off?
Maybe Debbie, if you can forward the few we didn't answer to me, and then anyone, I put my email in, feel free to send me questions, general questions, or if you have, scenarios about your house, like, hey, I'm thinking of this or that, feel free to reach out. I'll be happy to help you out. And thanks for your time and attention.
Yeah, thanks everybody. Have a wonderful evening. And Dave, thanks again for being such a fantastic resource for all of us.
All right, thank you, everyone.
Have a great night, everybody. Bye.